Tonight, when you drift off to sleep, something incredible happens. Your body takes over one of its most critical jobs all on its own, breathing. But what if that system just failed? Today, we are diving into a really fascinating condition where the simple restorative act of sleeping becomes a huge risk, and it's all because of a tiny glitch in our brain's internal autopilot. I mean, really think about it for a second. Right now, you can hold your breath, you can breathe faster if you want, but the moment you fall asleep, something else takes the wheel. So what is that something? And maybe more importantly, what happens if it breaks down? Let's get into it. Well, that something is your brainstem. You can think of it as the ultimate command center, this silent, unconscious guardian that's running your breathing 24/7 without you ever having to give it a single thought. It is, for all intents and purposes, your body's biological autopilot. Okay, so let's start with how this autopilot is supposed to work. It's a system that's been perfected over millions of years, and it's designed to do one thing: keep you alive second by second, especially when you're totally out of it and at your most vulnerable. Now, the brainstem isn't just one single thing. It's got a whole command crew. You've got the medulla, the pons, and the midbrain. But the real captain of the ship here, the one calling all the shots for your breathing, is the medulla. That's where the primary control centers are housed. So how does it work? Well, it's actually brilliantly simple. Your brainstem is constantly sampling the amount of carbon dioxide, CO2, in your blood. If that CO2 level starts to creep up, boom, the medulla instantly sends out signals telling your body to breathe faster and to take deeper breaths. It's this perfect little feedback loop that flushes out the excess CO2 and keeps everything perfectly balanced. But what happens when that brilliant, simple system fails? This is where we get to the heart of the matter, a situation where the body's life-saving automatic response is, well, broken. The medical term for this is hypoventilation, and it literally means underbreathing. Your breaths just become too slow or way too shallow to do their job. And the result? Carbon dioxide builds up to dangerous levels. And at the same time, your oxygen levels start to drop. Now, a system failure like this doesn't just happen out of the blue. It's almost always caused by some kind of physical damage, a lesion, right on the brainstem itself. And that can be the result of some pretty serious medical events, things like a stroke, a tumor, a physical trauma, or even a bad infection. So here is the absolute key. When that brainstem is damaged, its ability to sense and react to rising CO2 just gets dull. It's like the alarm system has been unplugged. The body no longer gets the memo that it desperately needs to breathe more. And now, for the really wild part of this story. You'd think this would be a huge problem all the time, right? But it becomes uniquely and incredibly dangerous during the one time our bodies are supposed to be healing and recovering, when we're asleep. See, remember how we can decide to take a deep breath right now while we're awake? We have that conscious, voluntary backup system. But when we fall asleep, we lose that. We hand over complete control of our breathing to that automatic system in the brainstem. And you can probably see where this is going. If that one automatic system is damaged, there's no backup. The body's effort to breathe can just plummet to dangerously low levels, and there's nothing there to kick in and fix it. The absolute most dangerous time is during REM sleep, the part of sleep where we have our most vivid dreams. And here's why. Our muscle tone just drops off a cliff. The muscles between our ribs that help us breathe, they become way less active. At that point, you are relying almost 100% on just your diaphragm. So if the brain's signal to that one single muscle falters even a little bit, your breathing can just nosedive. So how in the world do doctors figure out that this silent, hidden problem is happening in the middle of the night? Well, it takes some real medical detective work, and they have to look for some very specific clues. A lot of the time, the symptoms are kind of subtle. Patients might just complain about being exhausted during the day or having trouble concentrating. But one of the biggest clues, a huge red flag, is waking up with morning headaches. That headache is literally caused by all the carbon dioxide that built up overnight, which actually makes the blood vessels in your brain expand. Now, it is absolutely critical to understand that this is not the same thing as the more common obstructive sleep apnea, or OSA. With OSA, the person is trying to breathe, but their throat is physically blocked. Think of it like a plumbing problem. With hypoventilation, the airway is wide open. The issue isn't a blockage, it's a lack of effort. It's more like an electrical problem. The brain just isn't sending a strong enough signal to breathe in the first place. So to be 100% sure, a regular old sleep study just won't cut it. Doctors need to use a special kind of overnight sleep study that specifically includes monitoring carbon dioxide levels directly. It's really the only way to catch that autopilot failing in real time.
All right, so once this dangerous problem has been identified, what's the fix? The good news is there are incredibly effective treatments that can get that safe breathing rhythm back on track during sleep.
Now, your first thought might be, okay, if their oxygen is low, just give them more oxygen, right? Seems logical. But in this very specific situation, that idea isn't just wrong, it can actually be really dangerous. And here's the wild reason why. Sure, giving someone extra oxygen might make their O2 number look better on a monitor, but it does absolutely nothing to fix the real problem, which is the high carbon dioxide. In fact, it can fool the body's already broken sensors into thinking things are okay, causing them to breathe even less and making that CO2 buildup even worse. The real fix is a device called bi-level ventilation, or BiPAP. It's like a smart breathing assistant that gives a little push of air to help the patient take bigger, fuller breaths, which fixes both the oxygen and, crucially, clears out that dangerous CO2. So let's be crystal clear here. The number one priority, the absolute key to treatment, is providing ventilatory support. It's not about just passively adding oxygen. It's about actively helping the body perform the physical act of breathing to make up for the brain's failing autopilot. And if the damage to the brainstem is permanent, then yeah, this treatment is usually for life. That BiPAP machine essentially becomes a new, reliable, external autopilot for the body every single night. It ensures breathing stays safe and prevents all the awful long-term problems that can come from this, like heart failure. All right, let's do a quick recap of the big takeaways. First, our breathing is run by a fantastic autopilot in our brainstem. Second, if that autopilot gets damaged, it's especially dangerous when we're asleep and our conscious control is offline. Third, to diagnose it, you absolutely need a sleep study that tracks CO2. And finally, the life-saving fix isn't just oxygen, it's ventilation support. You know, it's just such a powerful reminder that this simple thing we do, breathing in and out, is a true biological marvel. It really makes you stop and wonder, what other incredible automatic systems are working silently inside of us right now? Systems we just completely and totally take for granted until something goes wrong.